We've examined synoptic or meteorological data at weather stations over northern Vermont. We move on to climatological data, which gives you a representation about what atmospheric conditions were like in the past. If you click on this link over here, you'll notice the National Weather Service offices for the northeastern part of the U.S. Since we're in northern Vermont, we're dealing with the Burlington office. The data that you see here, there's less of it than there is for current or meteorological data because you need at least a 30-year time period to collect climatological data. And a lot of the stations that we've looked at so far haven't really been around for that long. So the current period for climate norms is 1980 to 2010. So most of the stations that you see here have records for that time period. We'll examine Burlington because there's a very long time period there, and we'll see what's been stored here so far for the month of July, and compare it to past climate normals. So what you see recorded here is the maximum and minimum temperature for every day, the average temperature for every day, and the total of precipitation accumulation for that 24-hour period as well. You'll see that the highest temperature of the month is shown here in red, the lowest temperature in blue, and the 24-hour precipitation amounts are listed in this column. Here, there's also data here for snow, which doesn't really matter that much in July. We'll compare this to Mount Mansfield, the type of data that's collected there. And you'll notice that the maximum temperature for Mount Mansfield occurs in the same day, but it's not nearly as high as it is for Burlington. Minimum temperature is actually much closer than they are to Burlington, which is interesting. And the precipitation amounts for these 24-hour periods are different as well. T here stands for a trace amount. That means that precipitation was observed, but there wasn't enough really to be recorded in the precipitation gauge. Other data that's shown here is interesting. It compares the current data to climate normals from the past. So let's have a look, for example, here at what the temperatures are like compared to normal here for 2015 up until now. So this again, you recall it's for Burlington. And what you see here in red is the record maximum for each day. In blue at the bottom, in light blue, is the record minimum for each day. In brown, you see the normal maximum and minimum for a given day. And then in blue, you can see the day-to-day variation for 2015. So it lets you compare January temperatures, maximum and minimum, to the climate record. What you see over here is that that for much of February and March, temperatures were actually cooler than normal. And you'll recall that we had a very, very late spring this year, or somewhat late spring. Once you get into April and May, you'll notice that temperatures are closer to normal. You can see that there are periods in May over here, like right here, where temperatures are actually higher than normal, and you get near record temperatures for parts of this month. And then finally, you get into June over here, and July, where temperatures have been pretty close to the normal in the Burlington area. For precipitation amounts, the graphs that we use for that are slightly differently to keep track of how things are compared to normal. What you see here in brown is the cumulative precipitation, and that tells you at any given point in the month how much precipitation is normal to have fallen for that year. So it's the normal amount of total precipitation to have fallen for a year at that point. The blue on top shows you the year that has the maximum amount of precipitation, or record high amounts of precipitation, whereas the red shows the years that have the record low amount of precipitation. Okay, so those years are 2000 and those are 2011 for the highest amount, and 1893 for the lowest amount. In green, you see the amount that has fallen in 2015. So to interpret this graph, what you'll notice over here is, I'm just going to loop this down a bit here. What you'll notice is that for the early part of the year, through May almost, there was less precipitation that fell than normal. You'll notice that the green line is below the brown line. Finally, for the month of June, you'll see a sudden increase in the amount of precipitation. We had a very, very rainy June, and that's enough to bring amounts actually to higher than normal. Right now, stands in July, we have a total accumulation of about 20 inches compared to a normal accumulation of approximately 17.5 inches. Okay, so we have a slightly high amount of precipitation has fallen this year, owing to mostly to the amount that's fallen in June. If you look at Mount Mansfield, what you will see is, let me make sure I can find it here. Yes, there it is. If you look at Mount Mansfield and you look at the same cumulative precipitation graph, what you'll notice is that about twice as much precipitation has fallen. You will see that the 2015 accumulation is about 37 inches, and that compares to a normal accumulation of about 40 inches. In any case, that's about twice the amount that's been observed at Burlington. And that's pretty much applies for all of Vermont. In general, the mountain stations at the top of mountains get about twice as much precipitation as the valley stations. So if you examined places like Montpelier, Morrisville, St. Johnsbury, and Newport, you would see precipitation values pretty much comparable to what you see at Burlington.